question with problem 1. Okay, state whether the polynomial is a function or not. If it is, give the degree. So basically, the definition of a polynomial is a non-negative integer x. A polynomial has a variable with a non-variable with a non-negative, there's an E in there, negative integer exponent. Okay, so in other words, the exponent cannot be a fraction and the exponent cannot be negative. In other words, the exponent cannot, if it's a fractional exponent, right, then really what it is, it's a radical. Okay? And also, if it's a negative exponent, then x to the negative n, then it's x to the 1 over n, right? So it's kind of like the same definition of domain, right? All real numbers except for when x is in the denominator and when x is in the radical, right? The only exception is when we had x as a sum of two squares. Okay. So in that case, so is this a polynomial? Yeah. Because it's a non-negative integer exponent, right? So the degree would be its highest power for x, which is what? 4. Is this a... It's not, right? It's a rational function, right? Okay. And... okay, so it's a rational function, it's not a polynomial. What about this one? Yeah, it's not, because even though we have the square root of x times the square root of x minus 15, right? If we were to distribute that, that'd be the square root of x squared minus 15 square root of x, right? Well, their inverses, right? They cancel, so you get x. So this is no longer x, but you still have that one. It's still a radical, okay? So in that case, it's not a polynomial either, okay? All right, good.
So it would be C.
Well, there's two no's, right? One is a product, and the other is raised to a non-integer power.
Oh, it's B.
It's B, right? Product was not part of the definition, right? So it's B. All right, good question there. Okay, problem 4, use transformations to graph the function. Any question with 4? We good? Okay. Do we need to go through transit? Yeah, let's go through these real quick. Okay. The parent graphs that, okay, we've got x squared is a parabola, right? And then we have x cubed. It's kind of like a parabola that's half up and half down, right? Okay, and then we have a linear function, right? That's just a line. And then we have a radical, right? Square root. That moves up and to the right. And then we have reciprocal graph, right? And we had asymptotes. And absolute value. And what does that one look like? Yeah, V. Okay, so you have to look at the parent. First thing you have to do is decide which parent graph does what we're looking at, does the problem apply to. And then once you look at that, then you have to decide, is the graph, which way is the graph moving? So if we have y equals to our function plus c, that's going to make the move, it shifts, which way? Like if we had x squared plus 2, which way is that going to shift? Well, then what does this do? This is running out. Where's my other marker? What does this do? This will move left. This will move left. 2, if it's inside the parentheses. If it's not inside the parentheses, then it's going to move up. So this shifts up C spaces. Okay. So if it's inside parentheses, x plus c, now it's going to shift left 2 spaces, and that's what this is doing here. Okay, and if it's a negative in front, like y equals to negative x squared, right? What's that going to do?
It's going to flip across.
Flip it, right? It's going to flip or reflect it, right? About which axes?
X.
The x axis. That is correct. Okay. So instead of opening up, now our graph opens down, right? It flips it. And let's see if there's any others that we need to be concerned about. Well, we'll go through it. If it's a f of x, then it's vertically stretches by a factor of whatever this number is. So in other words, if we have y equals to 3, x squared, right? Instead of coming up 1, 1, now it's at 1, 3 in this case, because of the whatever this number is, it's going to multiply, right? Because now, if we put 1 in here, right, squared, if it's just 3, we put 1 in, we get 1 out. But when there's a multiplier on the outside like this, now it's going to be 1 squared times 3. Now it's going to be 1 in and 3 out. And this would be negative 1 and 3. So it stretches it vertically by whatever this number is here. Okay? All right. Questions with that? Okay, so having said that, which way is this graph going to shift? Yeah, it'll shift to the left. And because it's x to the 4th, it's going to behave like, if it's even, right, it behaves like x squared, right? If it's even, it behaves like x squared. If it's odd, it behaves like x cubed, right? So what this graph will do is it kind of flattens it out. So with y, this one's thrown out, y equals to let's just look at x to the 4th. Instead of coming up like this, now it's going to widen out. That's just exaggerated, but you get the idea. It widens out on the vertex. So with x plus 4 to the 4th, now we're going, that was 4, right? Or 3, that was 3. Here's negative 3, so it's going to look pretty much like a parabola, but it's going to be like wider at the vertex slightly. And so if this was x to the 6th, it would widen out even more. X to the 8th, it would widen out even more, and so on. Okay. Okay. All right. So what's this graph behaving like?
X cubed.
X cubed, and that's going to go up 3. All right, good. Does anybody need to see that graph, or are we okay with that? All right. From a polynomial whose zeros and degree are given, use the leading coefficient of 1. Okay, let's go over this real quick. We've got zeros, negative 3, negative 2, 3, and degree of 3. So basically, you're using, this is number 6, f of x equals to a times x minus c1, x minus c sub 2, x minus c sub 3, and so on. Okay, x minus c sub n, depending on how many zeros you have. Now they're saying that a, this leading coefficient, is 1, so we can just drop it, because 1 times anything is just that same number. So if we have zeros that are negative 3, negative 2, 3 with a degree of 3, then what we're saying here is the graph is going to do something like this. Since there's only 3 of them, we'll only do it like that. Well, it could either be moving up or down, we don't know which yet. But this will be C sub 1, C sub 2, C sub 3. These are our zeros. Okay, so whatever these zeros are, we plug them in to here. So we're going to put in here f of x is equal to x minus a negative 3 for C1. And then x minus what comes next? Yeah, minus a negative C sub 2, which is negative 2. And then what after that?
X minus 3.
Yeah, x minus 3. Well, minus a negative, that'll be positive, right?
Yeah.
Opposite of a negative 3 is a positive 3, and so on, right? Okay, so from here, I'm pretty sure they want us to simplify that. Let me just double check that. Yeah. Okay, so from here, we have to, so this is what we've got, right? We've got x plus 3, x plus 2, and x minus 3. Okay? So we start with the first two and we FOIL it. All right? So okay, here's so we multiply the first two terms, right, and we get x squared, and we keep the parentheses because we're going to have to multiply this one too. And then the two outer, that'll be plus 2x, and then the two inner, so that'll be plus 3x, and the two last, that'll be plus 6 times x minus 3. Okay, questions with that? Okay, well, we have to combine like terms, right? So 2x plus 3x is 5x. So that's x squared plus 5x plus 6 times x minus 3. Okay, questions? So now we take the binomial and we multiply it into the trinomial. So we start with x and we multiply x times x squared, x times 5x, and x times 6. So x times x squared is x to the what? Cube, right. X times 5x is plus 5x, what? Squared, and then x times 5 is 6x. And then we multiply the outer, right? The second term, negative 3 times x. And I like to use these arches here. Start from the outermost terms and work your way in. It just works out better that way. So negative 3 times x squared is a negative 3x squared. And negative 3 times 5x is a negative 15, right, 15x. And negative 3, 6 times 3, that'll be negative 18, right? So now we want to combine like terms, right? And I like to use the tally system. Start with the highest exponent. Look all up and down. We only have one x cubed. Nothing to combine there. So now we have a 5x squared and a minus 3x squared. That'll give us a plus what? 2x squared. Good. And you got a plus 6x and a minus 15. So that'll give us a negative what? 9, right, 9x. And so the only thing that's left to combine with the constant, nothing, right? Because we've looked and we've marked everything. So So when you're getting so many terms here, it's a good idea to use this tally system to make sure that you're not missing anything. Let me get this door. Hopefully this isn't going to be too long. Okay. All right. Any questions there? And so that's our answer. Okay? All right. So we have to plug them in and then simplify it. Okay. Number 9, or, oh, wait a minute, 7. For the polynomial, list each real zeros and its multiplicity. Determine whether the graph touches or crosses. Okay, so the zeros are where we take each factor with an x in it and set it equal to 0 and solve, right? So if we have number 7 is f of x equals to 3, and then x plus 7 times x minus 5 squared. Well, the square, right, is the same thing as if we said x minus 5 times x minus 5, right? So we don't write it twice, we just put a square. So just like finding the x-intercepts or the zeros for a polynomial, right? If there was no square there, we just set each factor equal to 0 and solve, right? So we get x equal what? Negative 7. And x equal to 5, right? So that means that our graph is going to that's the other way. That means that our graph has a 0 at 5 and a negative 7. Now, how did I know that it touches at 5 and crosses at 7? Because we look at the multiplicity. So this is 5 with a multiplicity of 2. Because it's multiplied twice, right? Multiplicity, so multiplied. So 5 was multiplied, this factor was multiplied, has an exponent of 2, right? So it has a multiplicity of 2. And then negative 7 has a multiplicity of 1. Okay? Because this is power of 1, right? If the multiplicity is even, then the graph touches. If the multiplicity is odd, then the graph crosses. Okay? So that's how we can tell if the graph touches or crosses. All right? Questions with that? Okay. Use the remainder theorem. So problem 8. Any questions with that? Use the remainder theorem. That's where we had to take this, set it equal to 0, right, like a factor, and then plug it in. And if use the remainder theorem to find the remainder, whatever comes out is the remainder. So if we were to use synthetic division, we would get the same remainder. Let's do that real quick. Okay, so this is problem 9. So we've got here f of x equals 2x cubed plus 7x squared minus 16x plus 18, and we want to know if x plus 9 is a 0. So in other words, we want to know, no, it asks, is it a factor? So in other words, is it this? Okay. So if it's a factor, then it's going to be a 0. So we want to know, is negative 9 a 0? Is it the graph going to cross or touch at negative 9? So we have to set x plus 9 equal to 0. And so we get x equal to a negative 9. Okay. So basically we'll take that negative 9 and substitute it in for x. And if we get a 0 out, then it is a factor. If we substitute negative 9 and we get anything else, we'll call this D, just for something else other than a 0, not a 0. This would actually be more appropriate. Then it is not a factor. All right, so we take our calculator. Okay, and one way we can do this is I'm going to show you a different way to apply this into your calculator. Is you take negative, instead of putting negative 9 in all this and putting in parentheses and all that, I'm going to show you a different way to do this. You put in your value that you're going to substitute in other words, negative 9, but you have to use this negative button down here. Negative 9. I guess it helped. I've got to turn it on first. Okay, negative 9. And then you're going to use this STO with an arrow. You're going to store that into X. So you're taking this negative 9, you're storing it into X. So wherever X is, negative 9 is going to be substituted into that. But we have to separate that somehow. So you're going to separate it with a colon. Well, the colon is down here at the decimal point. You'll see like two dots, like a colon, one dot above the other, and it's a green color. So you have to hit the alpha button and then the decimal point, because that's where the green colon mark is. And so you end up getting the colon mark on your calculator. Now at this point you just have to put in your function. X exponent cubed, hit the right arrow, plus 7x squared, hit the x squared button. And when you hit the x squared button, you don't have to hit the right arrow. Minus 16x plus 18. And good idea to double check that. Make sure that we entered in correctly. Okay. So we get 0 out. So can we say that x plus 9 is a factor? By definition, right? Can we say it's a factor? Yeah. because we get 0 out, right? So if we were to use synthetic division and put -9 in here, the remainder will be 0. And so this is a quick way to find if your factors are zeros or not. Okay? Question. You had a question? Did you get it? So let's go through this again. You got to put -9 in, right? But you have to use the little negative button here. Don't use the operation keys because that'll give you an error. You have to start the negative down here. So -9, and then you have to hit store, STO with an arrow, because you're going to store that into X. Okay? And you get this -9 arrow X. And then you have to hit second, and then the colon button down here where the decimal is. And then after that, you just type in your function, whatever your function is. And then hit enter. And this -9 automatically goes into every place where X is. Okay? And it calculates it out. So that's another way of showing you how to operate the calculator, substituting a value into the TI-84. Okay? Questions? So practice that. Let me know if you have any questions with that. And I'll post this video on so you can take a look at it again if you need to. All right? Yeah. See if I hit second and enter again, it calls it back. So I put -16x, and this is going to be the opposite operation button. That'll be this negative here. So only the first negative is this one. Every negative after that will be the operation buttons. Okay. All right. Any other questions? Okay, so try that. All right. So let's see, where else are we now? Use the remainder theorem. Okay, so that was 9. 8 is the same thing. So basically 8 and 9, you use the same thing to determine whether they're either factors. Use the remainder theorem to find the remainder. So in this case, we would find the remainder the same way. Make this a -1. So try this one, okay? Go ahead and do 8. The same way we just did 9. Okay, I must have missed 8. Go ahead and try it real quick. And while you're doing that, so you got to make that 1, x plus 1, you got to set it equals 0, right? Make it a -1, and then substitute it in. So try that. Okay?
So 9 would be yes?
9 is yes, yeah. Yeah, because we get 0 out. So with the difference between 8 and 9 is it doesn't ask you if it's a factor. Because for this one, you had to know if you get 0 out, then it's a factor. If you don't get 0 out, then it's not a factor. Whereas with 8, you don't need to know if it's a factor or not. You just need to know what the remainder is. Okay? So we put -9 and our colon button. X. To the fourth, make sure you hit that right arrow. Plus 8x. And it's a good idea to check as you're going along. Okay, so that's x to the fourth plus 8x cubed plus 12x squared. And that's it. Okay. So, that's your remainder. 1701. So So they don't ask you if it's a remainder or not. No, wait a minute, something's wrong here. Something went wrong here. X to the fourth. Plus 12x squared. What is that? Plus 8. Oh, cube? Yeah, no, that's right. Cube. Plus 12. Okay, now why is there a difference? Is everything the same? Well, that is odd. Okay, well that is the right remainder. Number 5 is 5. This should have come out the same way. I wonder if it still had the other 9 in there too. But anyways, just go ahead and do that. This is, I'll have to try to figure out why that didn't come out right later. Okay. Number 10. Use potential rational zeros of the polynomial function. Do not find the zeros. So you're trying to find the potential zeros here. So how do we do that? Let's go through that again. Do we need to see 9? No? Yes? No? Okay. Which one is P? We're using P over Q, right? Yeah. The last term, it's going to be your last term over the first, right? Last over first. You okay with that? We good? Do you need to see it? No? Yeah? Okay. All right. So, you've got f of x equals to 2x to the 5th minus 5x squared plus 6x minus 1. So with the potential zeros, you use the P over Q where P is your last term. Okay, Q is the leading coefficient. So P is your constant, Q is your leading term. So you're using 1 over 2. So you have to find factors of everything in the numerator and factors of all in the denominator. Well, factors of 1 is just 1. Factors of 2 is just 2 and 1. So I like to use the table method where P is in the numerator, or is in the top, Q is off to the side. So factors of 1 is just 1. Factors of 2 are 1 and 2. So you have, and you use plus or minus here. So this will be plus or minus 1 over 1, which is just plus or minus 1. And so this will be plus or minus 1 over 2. So our potential zeros are -1, negative 1. It's going to be plus or minus 1/2, and plus or minus 1. In other words, negative 1/2, negative 1, actually this is the other way around, it's negative 1, and then negative 1/2, and then 1/2, positive 1/2, and positive 1. So, before the TI-80, the TI calculators, you would have to find all potential zeros and then substitute them into the polynomial one at a time to see if you get 0 out, and then you could start using synthetic division. But since then, you could plug this into your calculator, go to the table, wherever your Y column is 0, those are your zeros, and you can start from there. But it still helps to know what your potential zeros are, to know where to start. Whether you have to start off near 0 to look up or down, or go from there. So this is your answer. This is your potential zeros here, okay? And you have to make sure that you use plus or minus, because if you're not, you're only getting half of them.
And you said it cannot repeat once you do that method, right?
Is what?
It cannot repeat if you do that method.
Yeah. If you get like 1 again, you just cross it out, because you don't put 1 and then 1 again, right? So yeah, good point. They don't repeat. So do we need to see number 11? No? Okay. Okay, how about number 12? Find the domain. Okay. Now with our domain, right? We said that our domain of a polynomial is all real numbers except what? 2 cases. Yeah, x is in the denominator, right? And when x is in the radical, right? Now if you get the only exception to this one is if you had the sum of 2 squared, like x squared plus 9, right? Then or just x squared plus 1, or x squared, when you get an x squared plus a number, then this is the only time that you don't get that this doesn't apply, but otherwise it does. So in this case, so if x is in the denominator, then we set x equal to 0, then solve. And if x is in the radical, set x equal to greater than or equal to 0, then solve. Okay? So this domain, number 9, is what? X is not in the radical, x is not in the domain, denominator, so that's what? All real numbers, all real numbers, all real numbers, right? All real numbers. Well, what about this? Is that all real numbers?
No.
It's not, right? Because we got an x in the denominator. So what do we have to do to find the domain? Set it equal, set the denominator equals 0 and solve, right? So with h of x, this is number 12, h of x equal to 2x over x minus 8, we take our denominator x minus 8, set it equals, equal to 0, and we get x equal to 8, right? So if we were looking for the vertical asymptote, that would be right on, that would be the vertical asymptote, right? at 8. And that's where the graph will be anywhere but that, because here it's going to be, if we put in 8 here, we get undefined, right? It's undefined at 8. So therefore, we take this and we say our domain, and we're using set notation here, is all values in set x such that x is x is anywhere except 8. Okay? Because that's where our vertical asymptote is. All right? And we get undefined here at 8. Okay? So if we were to substitute 8 in, right? 8, we get 2 times 8 over 8 minus 8. We get 16 over 0. It's undefined, right? So that's why it's not all real numbers, because we get undefined at wherever we set this number to 0. Okay? Questions with that?